So this is one of those questions that all these questions they basically like stack on each other. Meaning, for example, what's going on here? The first thing it says in the sketch alongside AB is a tangent, okay, to the circle at B. And then it says CE is a tangent to the circle at C. So what that means is, according to the 10 chord theorem, right, this angle is equal to that one, and then this angle is equal to that one because of the 10 chord theorem. And then it says here, these are parallel. So as long as those lines are parallel, we have what you may call alternating angles. So this angle here is going to be equal to that one because of alternating angles. Furthermore, it says here, prove that ABC, right? We prove that it is similar to CDB. Well, that one is simple because we can already see that two pairs of angles are equal to each other in these two triangles. So we can start off by saying here D1 is equal to B2. The reason for that is 10 chord theorem. 10 chord. And then the next thing is we can say that B1 is equal to C3. The reason there is just alternating angles. It means the last pair of angles is going to be equal. Reason being interior angles of a triangle. So let's mention that. I'm going to say here C2 is equal to A. The reason is interior angles of a triangle. And then question number 2 says the following. Question number 2 says, is asking us to prove that CD over BC is equal to AB over that. No, before we even do this, we have to say, we have to say therefore, triangle ABC is similar to triangle CDB. And the reason here will be angle. So for the next question, right, the idea is, if you're going to work out this next question, you need to keep in mind that AB over CD, AB over CD is going to BC over DB, BC over DB, which is equal to AC over CD, like that. Now we know this because of the proportionality theorem, theorem. Now the big idea is, because we know this, right, and because of what we want to prove, you see here there is CD and BC. So we can say a CD, there's BC there, there's AB and BD, AB and BD. We can just take these two, just cross multiply them. Cross multiply them, you have this times that, right, which is CD times that is equal to this times that, which is AB. This can write it up around. See, not a difficult question, but all this, we're actually gunning for question number 5. But before we get all the way there, we need to just see how all these things are lining up. The next thing is, we need to prove that CDE, so there's CDE, that's this small triangle here. We need to prove that it is similar to BCE. Okay. Now, in this kind of equation, the fortunate thing is you already know that this angle is equal to that one because of the 10 chord theorem. Now, the other thing is, the only way these two can be equal to each other is if they are both 90-degree angles. Or rather, we should take hints. Remember, this C is equal to this D, and this D is equal to this C, and then this E is equal to this D. That's, common angle. I guess we're done then. So the two sets of angles that we're going to use is the E the two pairs of angles that we're gonna use, it's the E and then the C1 and P1. And then the third one, we'll just say they're equal because of the angles of the triangle. So let's start. So for question three, we're gonna say E is equal to E, common angle, common angle, and then C1 is equal to P1, P1 equal to P1. The reason is 10 for theorem. And then lastly, we can then just say C2 is equal to D2 in triangles of a triangle. Which is equal to D2. The reason is interior angles of a triangle. So now with all that being said, you can say therefore triangle CDE similar to triangle BCE. BCE. The reason is angle. Great. And then we need to prove that BC over this is equal to CD over that. Same idea. We know that this over this, CD over BC is equal to DE over CE, DE over CE, which is equal to CE over BC, CE over BC. Over BE, sorry. And then we just have to look out for which letters we have there. We have BC and CE. There's BC here, CE there. Then there's BE and CD, which is just this and this. So we take these two together, we just cross multiply. It's going to be BC dot CE is equal to CD dot CE. You see, locate exactly what they want us to have. And then question number 4, because remember, we're trying to go towards question number 5. That's actually our main target. 4 says, 4 is what we proved. So with this question number 5, I want us to prove that BC over CE is equal to all this going on and on and on and on and on. Now, the one thing I can already see here is let's try and see if we can make use of this and this to help us, But before we do that, yeah. So let's see if we can make use of those. So you see here, there's a BC here and there's a CE, which is this and this. And then there's AC though. AC is this line over here for this one triangle, which we did AC, we have AC over here somewhere. Then we have BD, there's BD is somewhere there. We have DE is somewhere in this one. And then lastly, we have CD. So it looks like, yeah, whatever expression is here, it's just, yeah, it's a bunch of letters that are in both sets of triangles that are similar to each other. So yeah, it's gonna be quite interesting to see how we're gonna bring it all. Excuse me. It's gonna be interesting how we're gonna bring it all together because yeah, it looks quite interesting. But let's see what we can do. So there seems to be. Let's see here. Let's see what we can do. There is CD there, CD there. There is BC here, BC here. There is CE here, there is CE there. And then there is BD here, there is BD there. And then what else? What else, story bro? Come on. Let's maybe take red. Give me red, please. And then there is BE here, and then there's BE there. The only things that are not there is like AB and AC. Let's see where AB is and AC. So AB is this line here. AC is that line over there. What a wow. What a wow. So, yeah, like where there's fire, where there's smoke, there's fire. So we can try and link things together, So fortunately, there's BC in both in both expressions. There's BC in both expressions. There's CD in both expressions as well. So yeah, that is something that we could definitely try and and have a look at. The only sad thing with this kind of equation is that we don't know what the mark allocation is. So we would also be thinking, but what's the strategy? What kind of a strategy do we need to use for us to end up with something like this? Which is a good question because you really want to strategize without us just doing random things. So what we're seeing is there's BC and AC in both of these statements. You see there's CD here, there's CD there, there's BC here, there's BC there. Those are like the common ones. So let's see what happens if you isolate BC in one of them and isolate BC in the other one. So BC here would be equal to AB dot DD. The whole thing would have been over CD, right? If you isolate BC on the other one, you would have had BC is equal to CD dot DE, and then you would have had the CE, and then what else? Whoa. Oh, this mic wants to run away. So even if you make this equal, where is BC? BC is a common side. Yeah, if you make them equal to each other, it doesn't seem like it's gonna do anything really because BC would just disappear. If you had made CD the subject of the formula for both of them, yeah, it seems like you still end up in the same mess, you know? Seems like you still end up in the same old mess. So yeah, man. I feel like I need to pause and think about this one because it's really not a straightforward question, you know? Really not a straightforward question. But let me see, what would I do? What would I do? Seriously, come on. Come on, brother man. Come on. What would you do? Oh no, I know what to do. Do I? Let's isolate BC in the first one. Let's isolate CE in the other one. And see what happens. So in the first one, you're gonna isolate BC here. You're gonna have BC, right? Equal to AB dot CD over CD. In the other one, if you isolate CE, you're gonna have BC here. No, you're gonna have CD dot BE, the whole thing over BC, like that. Now, if you write BC over CE, it would be this thing here, right? Divided by this thing here. That's gonna be interesting. So let's take this whole thing and copy it. Copy, take it down. Take it down. Pam param. Pam param. Change style pink. Pam param pam. Regeneration X. Okay, so what we're saying is we wanna say BC over CE. So BC over CE, right? This is equal to this whole expression here. Let me see here. Let's see, ABBD over CD, right? This we're dividing it by this whole thing here. CD, CE, like that. So if you flip this over, you're gonna have AB, BD, CD, right? If you flip this over, you're gonna have this on top. Oh no, this is the bottom. Doesn't seem like it's going anywhere, bro. So this over this. If not, oh this. Yo. Dang it, Brody. Dang it. Then you have CD squared dot DE. Yup. Has this helped anyone? Nope. Doesn't look like it's helping anyone. AC. Where does AC even come in though? Yeah, now, yeah, let's see what we can do. Let's maybe take, well, there's something with AC over here. Let's, let's take something with AC over here. This has AC in it, and this has, where does something have AB now? This is AB and AC. So these two, let's try and take them together and see what we can come up with. Because the rest is just not doing anything, you know. Why did I call here when it's supposed to be 5? Oh, didn't we just do question 4? Ah, question 3. 3, no, we proved similarity in question 3, and then we did, this is question 4. Question 4. The one after it is not question 4. Question 5. So you can see, yeah, this is more like a textbook question, so that's why it's a bit annoying, like really not straightforward. And you may be wondering, oh, dude, why are we taking so long with this question? You know, at this point, you're probably thinking, oh, I'm just going to skip this in the exam. And I understand, I really do. But anyway, let's see. AB here over CD. This is equal to AC over CB. And then, with that being said, what can we have there? AC. But AB did not come. There's no AB anyway. Ah, come on, gentlemen. Come on, bro. Might as well leave that. B. What about BD? Is there a BD somewhere? There's a BD there. This we might as well leave it out. Let's take this one. BC and DB. BC on the top, DB at the bottom. How is this going to help us? Is there a BC anyway? Let's isolate BC. BC is equal to AC. This here you would need to multiply by BD on both sides. So let's do BD here over CB. Okay. Now the CB is the problem. Let's see where CB is. CB is this line here. CB is the same as BC. So, we'll cross multiplied here or something. If we cross multiplied with what we have here, we'd actually end up with BC squared. And I guess that does not help us in any way, does it? BC squared is equal to AC dot BT or DB rather. Yeah, this does not help us much because I mean there is not D. There's DB here. There's AC there. Okay. I guess I don't know. Could do something with it. Could be. Yeah. Where is EC? Something with EC. Well, we can definitely see something with EC here. But we need CD, BE, CD and BE. CD and BE. Well, there's CD there. Well, these two already. Well, if we take this, I don't know. What can this get us? It's actually CE here. You're gonna have CE equal to CD dot BE over BC. So if you make what do you call now? What are you gonna have? Yo. Goodness, bro. This divided by this, BC squared over CE is gonna be AC dot this, right? If you're gonna divide by a fraction, you have to what? So dividing by a fraction, right? What we know is you can put this over 1 and then divide by the fraction. So you can just flip it over and multiply. So dividing by this fraction here, I get C, D, B, B, E, the whole thing over BC, right? Flip it over, you have AC. What is this now? DB. Is it? Yeah. I mean DB rather. To the multiplication symbol BC over CD, CE. Yo. This seems so messy now, you know? Yo. It just seems messy. Let me just stop for now.